Hey everybody, just wanted to spend a little bit of time reviewing some of the big ideas for the Alchemy 2 test coming up in chemistry on Monday. Want to talk a little bit about the periodic table card sort thing that we did first. Main things to know for this are the patterns in the periodic table, things like the atomic mass. Okay, so as you go down a group, atomic mass should increase. And also as you go across a period, atomic mass should also increase. Okay. Other things, size. If you look at the periodic table here that I have, the size of the elements increase as you go down a group. Same thing over here on this side. So the size of them gets bigger because they have more mass as you go down a group, which means there's more stuff packed into that atom, so basically it's going to get heavier. Over here on this side we have the noble gases. These things do not react with anything. Okay, so they don't react with anything. Then we have the halogens, these right here. Fluorine, chlorine, bromine, and iodine and acetine is down here. You can't see it. Over here we have the alkali metals. Okay, things like actually hydrogen is a nonmetal, but starting with lithium, sodium, potassium, rubidium, those are alkali metals. Very reactive as you go further down here. Remember, this is one of the activity, kind of reactivity centers over here in the periodic table. Over here we have the alkaline earth metals. So these things, as you go down, get more reactive as well. Things like beryllium, magnesium, calcium, and strontium. Strontium is very reactive with water. Okay, so there's those things. When you look close up here, I'm going to talk a little bit about patterns in reactivity. Lithium, for example, we watched a video in class. It does react with water. It's not super reactive, but it reacts anyway. Sodium begins to react a little bit more quickly, a little bit more violently. Potassium, even more so. You can read some of the things on there. And then rubidium is so reactive that it actually can explode when it contacts water. So you can see as you go down that column on the periodic table, these things get more and more reactive. And so if we were to ask you a test question on that, we'd expect you to be able to predict how reactive these things would be, and then what types of compounds they would form with, and if you'd be able to find the atomic mass and things like that on the periodic table. Okay. So there's the major patterns that we need you to know for the periodic table for the test on Monday. Also, the test review. I want to talk for a second about some of the questions here. Describe the difference between an element and a compound. Okay, let's say I have something like, we've used copper sulfate quite a bit. So copper sulfate, one of the main things we saw in the copper cycle, doesn't matter if it's solid or aqueous, it can be either way. Copper sulfate, is it an element or a compound? The answer is it is a compound, right? Because it is composed of more than one element. So we have copper, which is an element, we have sulfur, which is an element, and we have oxygen. Okay? So these things are all elements on the periodic table, and combined together, they can form a compound. So compounds are made of elements, and elements basically can't be broken down into anything that still retains the properties of that substance. So we can't take copper and cut it in half and have it still be copper if we're talking one single atom, because if we break that apart, we're going to get down to what makes up a copper atom, and once we get to that point, it no longer is a copper atom. It's, protons, electrons, neutrons, things like that. So that's what we'll get into next week in class. Okay. Number 9 on your test review says, when a clear solution of lead nitrate is added to a clear solution of sodium chloride, a clear solution of sodium nitrate and a yellow solid are formed. Okay, we went over a couple of these in class, so I'm not going to go over that specific example, but I'm going to use a different one that I'll write out here on the board. So if you take NaCl aqueous, which is it's table salt dissolved in water, and you add silver nitrate to it, you are going to get sodium nitrate, NaNO3, aqueous, and something else. Okay, so question is, what is this thing over here? All right, so we've gone over a couple of these in class, and basically the way you tackle these, take a look at what the product was. Okay, so remember, these over here represent before you reacted anything, and then these over here represent what you were left over with after the reaction. Okay, so if we start with salt water and silver nitrate, okay, we get sodium nitrate back. Where's the only place you could have gotten that sodium atom from? Couldn't pluck it out of thin air. It had to come from somewhere, and it came from the sodium over here. So this sodium has now gone over here into that. Okay, you look at this over here. Where did I get the NO3 from? Well, the only place that could have come from is someplace over here, and that's right here. Okay, so this NO3, this nitrate, is now living over here with sodium. Okay, so what are we left with? Well, we're left with Ag, which is silver, and Cl, which is chlorine. So we know that the thing we end up with has to be something with silver and chlorine in it. So over here we're going to have AgCl, okay? And on the test it's going to be multiple choice, so I'm not going to have you write out the specific formula because we haven't learned about balancing ions yet, okay? But AgCl would be what you're left with, and if you look at most of the questions, it says it's a solid that you're left over with. So most of the time it's going to be a solid unless it tells you it's something that's aqueous, okay? So that's kind of how you do these problems, all right? Question 12 says, suppose you have an equal amount of calcium in 2 beakers